Yeah, good morning, everyone. Thank you for taking your time on a Saturday morning to attend this amazing conference. And yeah, I think we are all here to learn something, to share, and yeah, let's do that. So today's session from my side is finding your Lego, building an AI-powered image search with Fabric and Power BI. To start, this is maybe not like a very typical session where I just focus on one single feature, like in Fabric or in Power BI, but it's rather a combination of different topics. So it's also a bit of a reflection of how I am as a person. Like I struggle sometimes to focus and say I just want to do Power BI or just want to do Fabric. There's so many interesting things going on in our space, and I really find it very interesting to dive into different directions and to experiment. And this is how this topic and session also came about. So let me start maybe with saying a few things about myself. My name is Roger Unholz. I'm in the space of, I would say, Power BI and in general, business intelligence, data analytics for over 15 years now. Started my journey with the typical on-premise world, SQL Server, SSIS, AS, and so on. And now over the years, did the journey into the cloud, into Power BI and Fabric. I'm based in Zurich, Switzerland. And yeah, as I said, I've been in this space for quite some time now. I work as a partner and a solution architect at BSG. We are a consultancy company based in Zurich, Switzerland. And yeah, we do projects basically building data platforms, analytical platforms, mostly in Switzerland, sometimes with exceptions somewhere outside of Switzerland, but mostly in Switzerland. And yeah, I've had the pleasure to build a lot of solutions with different clients and been able to learn a lot. Another thing that I do besides my day-to-day work is I'm trying to be active as well in the data community. I'm one of the co-organizers of the Data Conference Switzerland. It's also a community one-day in-person event. We're going to have our second event or second year running this event this October. So if anyone wants to come to Switzerland, 22nd of October, the Data Conference Switzerland will be there. I think, Andy, you're going to be there, right? I'm not sure. I think you are there. But yeah, would be amazing to maybe see one or two of you guys. We'll bring together lots of knowledge in the Power BI and Fabric space, and yeah, looking forward to that. But let's dive into the topic. So this is actually what we're going to see and what we're going to do. This is a Power BI report that I built basically. And what we can do, this is a bit big. Let me go back here. So what we can do here is basically we can change images, and the Power BI report automatically finds images that look similar. And it's not doing it with text or labels or like the description, but it's doing it using really the similarity of the picture. And this is what we want to accomplish, that we basically can live search for images. I have a small daughter, so every time when I built this report, I had to come and show her, and she always wanted to see Elsa. So I had to do a lot of practice and testing with the model, basically like this, to see if this works. So this is what we are going to build. And let's talk a little bit about how it's done, how we can accomplish this. So let me move out. So basically, it's kind of like a reverse image search. So most of you are probably familiar with image search from something like Google, where you pop in an image and Google delivers you images that look similar. And how this is done technically, it's basically a machine learning algorithm that looks at your input and somehow makes it comparable to other images. And this is exactly what we are also going to do. For that, we have to learn something about vector embeddings or embeddings in general. Maybe you have heard the term embeddings. It's something also quite known in the space of ChatGPT. So if you started maybe to work a little bit with ChatGPT, then you might have come across the word embeddings. So basically, embeddings, what it does is it creates like a fingerprint of what you're looking at. And in, for example, ChatGPT, we know embeddings from if you have a large set of text or a large collection of texts, for example, a book. A book you can basically describe in many different ways. It has several features. For example, the number of pages, the genre, the author, and the language maybe. So there's a lot of different things that make this book what it is. And embeddings are kind of a machine learning algorithm that try to extract the essence of exactly that, of all of these different features together. So it basically makes from, for example, a text, it creates a numeric representation of that text. And the same goes with images. There are also machine learning algorithms that allow us to create embeddings from an image. So it goes basically through this machine learning algorithm, and what we get is a numerical representation of this image. So how can I do that? Or like what we are trying to do is basically take a source. In our case, it's the image of our Lego, basically like the top front image of the Lego box. We pop this into our Azure AI Vision machine learning algorithm, which is hosted in Azure Foundry. And what we receive as an output is a numerical representation, an embedding that is basically the fingerprint of that image. I'm not really a data scientist, so I couldn't do or build this machine learning algorithm from scratch. But that's why we have something like AI Foundry, or like in general, like these cognitive services from Microsoft that actually give us a lot of pre-built machine learning algorithms that we can just use, we can plug and play, and actually just then take the output from this machine learning algorithm. So if we talk now about embeddings, so I think a key thing to understand is why this is very useful is that it allows us to really get the context of something. And as I said, we saw it maybe with text, but it as well works with images. And when you have this combination text and image, we talk about multimodal embeddings. So it really also works not just for text, it also works for things like images or videos. Like also this kind of things you can represent as an embedding. And so what we see here is basically that, for example, the word chicken here, it's physically in this vector space. It's now here, it's kind of like represented in a three-dimensional space. And chicken, basically the word, is very close by to the actual picture of a chicken. And that's the key thing that we have to know about embeddings. So things that are very similar they are close by in the space in terms of where they are in this embedding. So that machine learning algorithm really always will create things that are close by if they are related or if they are very similar. So this is very important when we do then our search. What we want to find is other images that are actually like close by to us. So here, like a dog and, for example, a cat, they're not the same thing, but they are animals. That's why they are on close by, even still close by, relatively close by, in comparison to maybe something like a banana. A banana is not really related to a cat or a dog, to animals, so it is further away in this space. But banana and apples, they are again relatively close by to each other. So I hope you get the point. Basically, with this whole embeddings, what it allows us to do is to really find similarities by basically finding things that are close to us in this three-dimensional space. To be precise, the embeddings that we get, they are not 3D, but they have more than 3 dimensions. Just for us as humans, it's very difficult to visualize and to kind of like understand if we have more than 3 dimensions. So 3 dimensions we can understand, and that's why we simplify it in this way. But I think you get the idea. So as I was saying, like we want to find something that is close to us or relatively close to us. I'm not a mathematician, so I'm not going to like give you a lecture on the exact formula how this works. But in general, when we have vectors, vectors, at least that's as much as I learned in my university days, vectors is basically like indefinite line, basically a direction that is pointing to a way, and it's just going indefinite, right? So if we have two vectors and we want to actually compare how similar those vectors are, what is relevant is the angle between the vectors. So you see here, if the angle is far apart from each other, it means they are not similar at all. If this angle is basically 0, then that means that those two vectors are equal or very similar. So to find out if two vectors are similar, we have to find basically the angle. And this can be done with something that is known as the cosine similarity. So cosine similarity is also very often used in, again, in like the AI space when we try to find similar texts. Cosine similarity is the function basically that is used to do that. If you work with things like the Python, you have pre-built libraries and packages that allow you to use a function for cosine similarity. Now in SQL Server, there has also been quite a lot of development in this area, so that you can also use functions to find the similarities in SQL, basically. When I was building this report, I was thinking I want to do that. So I need to be able to do a cosine similarity using Power BI. I couldn't use directly the functions in Python, because in Power BI, I couldn't do that. So what I had to do basically is I had to create my own similarity function using ducks. We will see how we can do that. So when we have that, so this is the theory. So we need to get the embeddings, and we need to build this cosine similarity, or like this function in ducks that allows us to calculate the similarity. To look at the architecture of this solution, I started with a Lego catalog database. This is called Rebrickable. It's I'm going to show it to you just in a sec. This is basically an online catalog of all published Lego sets, and it also provides some downloads or APIs that you can actually use to search for Lego. So with that, what I did is I brought this into Fabric. I ingested the data. We enrich the data using a notebook. So basically, we took in this case first the CSV file of the Lego database. We enriched it using a notebook. And with this AI service, we pop in basically the image, and the machine learning algorithm returns for us the embedding, like the vector representation of this image. What we then do is we store that in a lakehouse table. And once we have the lakehouse table, we take that from there, we build our Power BI model, and we do our report basically on top of that. All right, I think enough theory. Let's jump over to Fabric and to Power BI, and we can see how this is done. So I'll start here very quickly. So this is the Rebrickable website. So if you go to rebrickable.com/downloads, what you get is basically here the sets, or like the parts that you can download. They also have, as I said, like if you create an account, you can also do get this as an API. I chose to go the easy way for simplicity reasons. I just downloaded quickly those CSV files, mainly the sets. So this was the part that was mainly interesting for me. And I basically brought this over here to Fabric. So we are here in Fabric. I have, for example, here in my files, I have the sets and the themes. The themes I'm not really using right now, but if we have a look very quickly at the CSV file, it's just a normal CSV with a comma delimited. You have a set number, like a unique identifier. You have a name. You have the publication year. And then you have some more information like the theme ID, the number of parts, and for us, important, you have the image URL. So that's basically all we need to get started. And so what I did now is, as a next step, so I just took basically the CSV and stored it as a delta table. And if we just do a quick select, again, we see the same information that we saw in the CSV file. We have the set number, name, year, and so on. And we have the image basically of the cover box. So this is the images that we're going to use then to retrieve the embedding. So let's do that. In order to do that, in order to be able to use the embedding, I used an AI service called Computer Vision. So you can find here the link. Basically, it's just the documentation basically about all the different vision APIs that we provided, or the vision models that are provided. So you can really go in here and have a look what is provided. I used something, if we search for embeddings, multi-model embeddings, it's this one here. Just very small remarks, or like some information. You will also see this in the website here. These models are basically general purpose models. you should not use them to do things like, I don't know, like cancer recognition and this kind of things, because it's not built for that. So like this kind of health detection things, it's not trained for that. So it's really just a general purpose model. And so use it as well for that. It will give you also a lot of disclaimer about this kind of things. But yeah, here you can really go and look at all the different models that they provide. For our use case, as I said, what I need is the embedding model, the API, so that I can retrieve from an image the embedding representation. How did I do that? So I published my my model here in Azure. Once it's published, what you get is an endpoint, and you get an API key that you can use. And with that, we are basically good to go. I'm using here the Spark notebook again. I'm using Python, where I have the information of my model. So I have the endpoint and I have my API key. I learned we should keep this kind of things secret in an Azure Key Vault so that we can have that nicely securely stored. So I create a function that retrieves the embedding for me. And as a parameter, I'm just passing the image URL. I hope it's big enough. Let me do it maybe a bit bigger. We can see it well. All right. Yeah, I'll skip this part a little bit. So this is basically just the preparation to call the API. So it's really basically here, I would say the relevant part is basically here. So I'm just calling the API here, saying, okay, do a request, post request with the URL, basically, and then just the header information where I have my API key. And as a return, what I receive is basically here, it's the image vector, basically, that I receive. Yeah, and so what I do now is, I can maybe show it here very quickly. So if I run that, is I first select my Lego sets. In this case, I just limited it to 5 because I don't want that we have to wait. But basically what I receive, so remember the picture before, we only had the image URL. And now on the right-hand side, this is now what the model returned us. And you can see it's an array basically of numbers. So you see here, here's position 0, position 1, 2, 3, and so on. This embedding returns for each image an array with 1024 entries, or like 1024 numbers. So you see like they're all like numerical representation. That's the output that we get. And this basically I stored now again into a lakehouse table. That's this cell down here. So that we have a lakehouse table with sets and embeddings. And that's what we have here. So I thought, okay, now with that, I'm good to go. I can now just pop this into Power BI and I can move on and just do the function. But I had to learn, or I found out that actually Power BI doesn't really like an array data type. So it was struggling basically to recognize that this is an array. So natively, Power BI don't has this data type. So I couldn't really work with it in a nice way. So what I had to do, or what I did then basically to overcome this limitation, is to create me again another table. And basically for each set, I just kind of like create for each entry in the array, I create an own entry in this table. So as I said, we have 1024 entries in the array. So you see here, those sets is always the same set. So for each set, I will have 1024 entries in this new table. And you will always have here the ID, like the position of the array, in this case 0, and then the value here of the array. Wait, sorry for that. And with that, basically, I don't have an array data type anymore. I just have a table. It's a larger table because I have for each set 1024 entries. But at least now with that, I can take this over to Power BI and work with it. So that's what I did. How could I do that? I used a Python function called post-explode. This allows me to relatively easily, basically, you can see it also down here. This allows me to very easily create basically from this array just kind of how you would use it in SQL. It's probably an unpivot kind of, that you kind of unpivot the array so that you have rows. All right. And this again, we store as a delta table called set embeddings. And with that, we are basically good to go. So if we look again at one example, so I have now in this new embeddings vector table, I have for one single set, I get the 1024 entries. And you see here like position 0, position 1, and so on. So you can see up until 1023, we will have basically this representation of the vectors. Good. So that's all the magic we have to do in this Spark notebook. And with that, we can now jump over to Power BI and look at this. So if we go here to my Power BI desktop or my Power BI file, let's maybe start with the relationships. Let's make this a bit smaller. So what I have is, as a starting point, I have this set embeddings table over here. And I have the set embeddings vector. So this is this large table with all the vector ID and the value that we just saw before. So those are the two tables, main tables that we need, basically. I retrieved them just directly from my lakehouse from Fabric. So there's zero transformation going on here. It's really just a loading, basically, of the table. And so I connected them together with this relationship. We have the set number that is the unique identifier of the Lego set. And with that, I think that's all we need. What I as well created is this set selection table. This is basically like another related table. I'm not connecting it really to anything. What I'm using this for is actually to do the selection. So if we look at the report here, we have this slicer, and this is actually coming from this set selection. So when I change here a selection, I don't want it to automatically filter just for this one image, but I want to use that basically then in my DAX calculation that we will look at just now. Okay, but for that I needed to create this set selection, but it's basically it's coming from this set embeddings. It's just some DAX code here that is using the set embeddings basically to visualize it. All right, and let's go to the probably a more tricky part, which is the DAX measure for the similarity. As I said, if you remember this similarity, it was basically, maybe if we go back quickly to the slides, just to have a look again at it. So if we look at it again, it's this mathematical formula basically. And what it is kind of A and B are the vectors. So we have A and B, like the selected vector and the one that we want to find. And so we have basically the sum of the multiplication of those two divided by the square root of basically this vector A and the vector B. So I tried to replicate that in DAX. So that's what I did. Let me also try to make this a bit bigger so that we can read it. So remember that I needed to have basically vector A and vector B. In my case, vector A is this unrelated, like this slicer that I do a selection. So first I select an image and say I want to have this one image. Find me all other images that are similar to that. So this is basically this part here. So I'm taking the selected value of the slicer basically. So this is the set number that I selected. And then what I do is I get me the table of the vectors for this selection. Remember, we have the two tables. We have the set table and we have the vector table. And so the vector table is going to have the 194 entries for exactly that. So it's this image, and with that I will get the table with its corresponding vectors. And then now down here, it's this cosine distance that we calculate. And if you remember the formula, that's basically what I try to accomplish. What we do is we iterate basically through this vector table. We have, because you always compare this position. So I compare position 1 with position 1 from the other image. So it's always like that. You always go from position to position. That's why I can use basically like this iterator function in DAX, where I iterate through this vector table, and I say compare me from the selected value from this guy here, compare basically with the same position. Like if your position 0, compare with position 0 from the other image. And that's what I then compare here. That's what I get here for this selected vector value. So, and then I do this exact calculation as we did before. So it's dividing the multiplication from selected vector. So that's my selected image. Multiplied with the current vector value, then it's the division, the square root of those two vectors, like this is the A and this is B. And with that, basically, what I receive is distance, basically the distance value. All right, and this now I visualize now in the report. So that's basically what we see over here. And if we maybe look at it in a table way, so or I can maybe hover a little bit, then we see we have here the similarity value. So that's what you see here. That's actually the measure that we calculated. So the closer it is to like 1000, basically, the more similar they are. So if I see here 780, so they're less similar, but still quite similar. For this image, or how did I do this? So I'm using here, let me pop up the visual so you can see it. So this here is a button slicer. But in this button slicer, I included actually the image so that we can see the image. And in the tooltips, I have the similarity. And here for the filter, because I don't want to have a list of all the images, I just want to have, in this case, the top 6 images basically descending to have the most similar ones. If I would change that number here to, let's say, 10, then I would receive more images. But you get the idea behind this. So it's always going to use that. And I think here, yep, here this should be descending. So you have here a descending order. And like that, I have basically the images that you can see here. Yeah, that's the whole trick. The rest is really just report design, basically. So I have a background image here. I have this slicer, which goes to the not connected table. And this is basically the image from this slicer. And the rest is really the live calculation index. And yeah, when once I got it to work, I was super happy. It took some time, but yeah, it was a good learning for me, good learning to learn about embeddings and as well how you can accomplish such a thing. I want to go now maybe a little bit back, or just take a step back and show you another thing, to maybe also like try to explain why this is actually something that also is very interesting. At least for me, I think it was quite interesting. So you remember what we saw with the three-dimensional space with these embeddings. So as I said, in our case, our embeddings, it had 1024 dimensions. So it had 1024 entries in this array. And this is something that we cannot really picture. So what you can do, so I have here, again, a Spark notebook that actually reduces this to 3 dimensions. So I didn't come up with this, so I used here a bit of ChatGPT to help me. But basically what it does is it reduces this 1024 to 3 dimensions. So it uses some libraries here in Python that now take our embeddings and reduces it into 3D, and it creates also some clustering. And what we get then is basically an image. I plot this now here, and we get an image like this. And here you can really go and look into, this is all the embeddings and Lego sets that we were just looking at, just now shown here in this 3-dimensional model. And the color that you see is some clustering that it did based on the similarity. And if, for example, I look into these yellow guys here, so they're all Avengers, kind of like you have here Batman, yellow is Avengers. Yeah, they're all like Captain America, Avengers, and so on. Things down here, they will also be related. So it's all kind of like possible to look at this in this 3-dimensional space. It's this orange phone cover, book, yeah. So this is also, again, a different way how we can actually visualize data. It's really, for me, it was a really interesting learning to see how this actually works and what we can actually do with this. All right. If we go back to the presentation, let me just move on here very quickly. That's this. Yeah, I would have a few minutes for some questions. Question might be that you want to maybe have the code. If you say yes, you would like that, please just scan the GitHub repo QR code here. I made this public, so all the notebooks that you saw and the report, it's in the GitHub repo, so you can just download and try it out yourself. I did something similar actually with the sessions from FabCon that took place in Las Vegas just a couple months ago. So I basically took all the session texts and I did the same exercise. I extracted the embeddings of the session text, and you can find basically similar sessions based on the text description of the sessions. So it's again the same principle, but now instead of images, I use text. You can also find that in my GitHub repo. If you say you would like to stay in touch, please feel free to scan my LinkedIn. I'm mostly active on LinkedIn and post from time to time something that I find interesting or that I came up with. Yeah. Otherwise, yeah. Thank you for if there are no questions, I would say thank you for attending. Enjoy the rest of the sessions and the rest of the day. Yeah. Thank you.